My name is Chris Brothers. I'm the head of the science department for grades 7 through 12 for Falmouth Public Schools. And I have a partner in crime who was supposed to be here with me today, Andrew Cozzens, who's our physics teacher, but very last minute he got accepted into a 2-day workshop on astronomy at the Harvard Museum of Natural History. So I said, Andrew, you have to go. I'll do your slides for you. So if you look on my bio there, it says I'm an NSTA Eclipse partner. And what that means, that's the National Science Teaching Association. And back in the fall sometime, they published this Science Teacher magazine. And back in the fall, the whole magazine was about eclipses. And I looked through here and I said, wow, this looks great. We have to do something with our students in Falmouth. And it turns out that NSTA sponsors this Eclipse Partner Program for teachers. So I signed up for it on like midnight on a Sunday and got accepted. And so we're supposed to try to coordinate eclipse activities in our schools and in our community as well. And in one of the webinars that I participated in as a result of that, I also learned about this program called SEAL, which is Solar Eclipse Activities for Libraries. Both of those two programs are sponsored by the Space Science Institute. And the SEAL program basically is funding public libraries to host eclipse activities. So you'll see that this library has a number of eclipse things going on in the next 2 weeks and past few days. And they're also giving away 5 million pairs of eclipse glasses at 10,000 libraries across the country. So that's pretty amazing, and why you're able to get the glasses today. So I do want to just caution you quickly that when you take those glasses home with you today, be very careful not to scratch them or get a little tear or puncture in them, because you want to be protected, obviously, when you're watching the eclipse. Okay? Unfortunately, the remote is not working, so I have to come over here to do this. All right, so I think by the fact that you're here, you all know that this eclipse is happening on April 8th. Here in Falmouth, it's going to start at 2:16 and end at 4:39. It kind of blows me away that astronomers can say, we'll start here, end here. And believe me, they have it timed down to the second. I just didn't put that in the slides. And the maximum is going to occur at about 3:30 that afternoon. A couple people were asking me as they came in, like, how much are we going to see, right? That's what everybody always wants to know. So I have a little animation that will show you that in just a second. But this is what the, let's see, I brought this up already so that it would work. I'll go back here. Is that the one? Yes. So that's the path that the eclipse is going to take. And in the upper corner, you can see the time, in universal time, when it will be passing by. And so for us, there it is about 2 in the afternoon. And then down here on the bottom of this animation, when it starts again, you can see, I hope you're going to see, no? Here we go. The actual amount of time of the totality. So you notice that's actually pretty short. So most eclipses are between 2 and 5 minutes long in the totality. The whole event can take about 2.5 hours, going through the partial phases and then coming back out the other side. And for this particular eclipse, the totality is going to be about 4 minutes, 35 seconds, which is actually sort of on the longish side. There are some very enterprising airplane companies that are selling tickets if you want to be in a plane and see the eclipse from a plane. Because if you fly anywhere within the path of totality, you can get up to 7.5 minutes of totality. So for a few $100 extra, or a few thousand, because those are hot tickets right now, you can get 3 extra minutes of totality. So I'm just going to go forward to the next little animation that I have here. So this is what it will look like in Falmouth. And if you notice over here, there's the time in the bottom right corner. And so I'm just going to slide this across. So here it is at 2:15, and oops, sorry about that, 2:15 in the afternoon. So as I mentioned at the beginning, I'm a teacher in Falmouth Public Schools. So when I first started looking at the timing of all this, I was like, wow, that's just when our Lawrence School kids, that's like the last half hour of our day. And what if we all take them all out, in the soccer field and let them watch the eclipse? How much will they actually see? So starting at 2:15 and they get out at 2:45. So that's what they will see before they go home that day. And I was like, great, we can get some glasses. We can get a few, make a few pinhole projectors. We'll go outside, have all the kids watch the eclipse for half an hour. It'll be a lot of fun. And then I started thinking, we're going to put them all on a bus, send them home, and they're going to want to watch the eclipse at home. And now they won't have any eclipse glasses or any safe, protected way to do this. So I thought, let's write a grant and get some eclipse glasses. So I did that for the Lawrence School. And then I started thinking about Morse Pond School. This is what the eclipse will look like in the 5th and 6th grade. All the Lawrence School kids go over to Morse Pond and get on the buses and go home from there. And then I started thinking about the elementary schools, because here's what it's going to look like for the elementary school kids and for us at 3:30, which is our maximum. If I can toggle it just right, you'll see it gets to 90.3%. So that's going to be our maximum here in Falmouth at 3:30. So then I started thinking about the elementary schools. I'm like, this is really an elementary school event, because they will still be in school at the maximum. So then we decided to get glasses for all the elementary schools, and while you're at it, why don't you get all the teachers and staff? And so it ended up being 3 grants and 3,500 pairs of eclipse glasses, but not quite 5 million like the libraries are doing, but so every student and staff person will get a pair of glasses. And it's also important because when the older kids get home, we do want them to be able to watch safely. And we also thought, well, they'll be home with parents maybe, or siblings, or neighbors. Even their dog. I've seen dogs wearing eclipse glasses. Probably just faked photos, but anyway. Point is that all those kids will go home, they'll have a safe way, and they'll know how to be safe at home when they're watching the eclipse, maybe on their own or with friends. And also, it has sort of a multiplier effect, because if people down the street come over, hey, what are you doing standing out here with these weird glasses on? And then they can participate as well. So here's just going back out the other side of the eclipse so you can see what that will look like. So 2.5 hours altogether. By the way, this website has animations like this for 2,000 different sites in the United States. So you can basically go in there and type in your zip code or even just your town name, and it'll give you an animation. And it has a slightly different animation for East Falmouth and Falmouth, should you want to go and see if you can figure out the difference. Okay. Oh, so one thing too, one of the reasons why we were really psyched about doing this with kids is because the next total eclipse in the United States is not going to happen until 2044, so 20 years from now. Some people are saying this is a once-in-a-lifetime event. I hope that's not true. I think it's more like once in a generation, every 20 years or so. But I personally saw a total solar eclipse when I was 8 years old, and I remember to this day how awesome it was. It got dark, and birds stopped singing, and the fact that I remember it umpteen million years later obviously had a big impression on me. So I'm hoping that our kids will have that same experience and remember it, the rest of their lives. Okay, one of the things that also is making this eclipse sort of a special event is how many people live within the path of totality. So that's about 31.6 million people, according to NASA. And then 150 million additional people live within about 2 to 3 hour drive of the path of totality. So if you add that up, that's like, 200 million people, which is almost 2/3 of the country. And this eclipse is going to be visible in all 48 contiguous states and a teeny little slice of Alaska and Hawaii. It's not really going to be an event there, but basically it's the whole United States. We'll be experiencing this. So the path that's going up and to the right is the path that we're talking about now. So how many people knew that there was an eclipse last October? Like, I see like 4 people. Okay, it was pretty much a non-event around here. It was maybe about 20% maximum. It happened about 1 o'clock on a Saturday afternoon. I went out to the beach and I was geeking out with my eclipse glasses on, and everybody else was playing Frisbee and having picnics, and nobody was paying any attention to the sun or the fact that an eclipse was going on, because really it didn't look like much, didn't get dark or anything like that. And then it totally clouded over, and that was sort of the end of the event. But anyway, hopefully this eclipse is going to be a little bit more spectacular for us, because as you saw, it's not going to be just 20%, it's going to be more like 90%. Also, that eclipse that happened in October was an annular eclipse, and the one that's happening in April is a total eclipse, and we'll look at the difference between those. And as you can see, it's going to pass over the East Coast, so a lot more people are going to be in the path of totality. Unfortunately, the East Coast also sometimes has more cloud cover, knock on wood, so that could, be an issue, hopefully not. All right, so this was an eclipse that happened here in 2017. It was also a partial eclipse. How many people remember this one? Few more people. It was a little bit more noticeable. It was maybe around 40 to 50%. It got a little bit of media play, unlike the one in October. The path was, this is the current 2024, and that's the path from 2017. The path was a little bit closer to us, so we experienced a greater maximum than then. And some differences here, as I mentioned before, this totality is going to be longer than the eclipse from 2017. And the path of totality is also a lot wider, by about, 20 miles? Well, more like 40 miles. Okay, so that's putting a lot more people into the path. And that has to do with how close we are to the sun, and I'm going to show you, how close the moon is to us at that time. So I'm going to show you a picture of that in just a minute. And another reason why this eclipse is kind of getting a lot of attention is because it's going to happen during a solar maximum. And again, this is something I'm going to talk about a little bit later on, but that occurs approximately every 11 years, and the sun's going to be at its most active. So for astronomers, this is a relatively rare opportunity to be able to observe the sun. Okay, so a solar eclipse can only happen when there's a new moon, and the moon is between us and the sun. Okay, so how often does a new moon occur? Once a month, right? So in a year, how many new moons should we have? 12. So why don't we just have eclipse every single time there's a new moon? Right? That's a head scratcher. Okay. I see a few people doing this. I'm not sure what they're indicating, but okay. And I'm going to invite Porter, who has his hand up, to come on up here, because he's going to demonstrate for us why we don't have a total eclipse or an eclipse at all 12 times a year, and why these things are not as common as you might think they would be otherwise. Okay, so Porter, you need to hold these 2 hula hoops as best you can, like right on top of each other, okay? You might have to hold like further around. Yep, as best you can, all the way. Keep them flat. Those hula hoops are surprisingly heavier than you would think because they're kind of big. Perfect! Okay, now if we take the orbit of the moon around the Earth, and we also take the motion of the Earth around the sun, that's what we're representing here with these 2 hula hoops. And if they're lined up the way Porter has them right now, as best we can, they're in the same plane. And if they were like this, then yes, we would have an eclipse every time there was a new moon, because the moon would block the sun every month. Okay, Porter, can you arrange those 2 hula hoops like this picture? Okay, so the orbit is actually about 5 degrees off. It's not very much. It's totally exaggerated by Porter and by this picture, but that little 5 degrees difference makes literally a world of difference in terms of the eclipses. And it means that you can only get an eclipse here and here where the two orbits overlap each other. And that happens to be right around the time of the spring and fall equinox. So not surprising, the equinox was this week, and the eclipse is 2 weeks from now. Okay, so with those two eclipse seasons, and when the new moons occur, you can only get 5 solar eclipses of any type, total, annular, or whatever, per year on Earth. And not every single time there's a new moon. You good, Porter? Your arm's getting tired? Okay, you can put them down. Thank you. Okay, also because of that geometry, it means that if you're in a given location on Earth, you can only get a solar eclipse, a total solar eclipse, once every 375 to 1,000 years. So that doesn't mean we only have total eclipses every 375 years. Some people, like, on Facebook sites are sort of interpreting it that way. But no, like if you're on a given location, you will have it once every 375 years or up to 1,000. So for example, if you look at this, we go back a minute to the path here. I want to look at this. Okay, so this is Texas, right? I consider this totally unfair that Texas had an annular solar eclipse in October, and they're getting a total solar eclipse in April. So Texas was the place to be this year if you're an eclipse chaser. And also I want to point out that I'm from here, Rochester, New York. I also consider it totally unfair that my hometown is getting a total eclipse this year. But, that depends on where you live. All right, so there are 4 types of eclipses, and I've kind of been using these terms a little bit. Total, annular, partial. Okay, in a total eclipse, the moon completely blocks the sun, and we can see what's called the corona, which is sort of that white, wispy-looking thing around the sun. We'll talk more about that later. During an annular eclipse, the moon doesn't quite block the whole sun. So we see a little ring around the sun, which is called the annulus. That's why it's called the annular eclipse. And then if you're not quite in the path for either total or annular, you're going to see partial, where the moon doesn't quite cover the whole sun. Okay, is anybody experiencing any cognitive dissonance right now? That's an education term. You like that? I got a few former teachers in this room, and they're probably, oh yeah, cognitive dissonance. What are you thinking?
Well, it says 4 types of eclipses.
Right. There's 4, and there's only 3 pictures there. So what's going on? Well, depending on where you are for a total or annular eclipse, because the Earth is curved, you can, in some places, see an eclipse that looks total and annular both as the sun is moving. And it kind of like moves between the two. But that's a relatively rare phenomena, and you have to be like at the exact right spot where that is occurring for that particular eclipse. That's called a hybrid eclipse. I'm not sure if I said that. Okay, so a total eclipse occurs when we are in this part of the moon's shadow. Okay, I know that Porter is an eclipse buff back there, because when he came in, I heard him using these terms, umbra and penumbra. Porter, what grade are you in?
6th.
5th?
6th.
6th, okay. I don't think too many 6th graders know those terms yet. So, do you have Miss Trabou for a teacher? No? Okay. Okay. Because I know she was teaching about this a week or 2 ago, so she thought you might be in her class. Okay, so this shadow, as you can see, is darker and sort of more direct. It's more, it's cone-shaped and it's more focused. That part of the shadow is called the umbra. And if you are in that part of the shadow from the moon, you will experience a total eclipse like this. If you are on the sort of periphery of that, and you are out here in this more diffuse darkened area, which is the penumbra, you will experience a partial eclipse. Okay, there is also a third part of the shadow called the antiumbra, and if you're in that part of the shadow is when you can get that hybrid eclipse going on. Here you can see really nicely the corona around the sun there. So here we are with an annular eclipse. Now I will confess, at some point I thought that annular eclipse just meant it happened every year. Okay? And then somewhere along the line I discovered that wasn't true. Maybe it was in one of the webinars that took place in this year, but it has to do with where we are in the orbit of the moon around the Earth, whether you get that total or annular. So if you notice, if you're sitting up front, you might be able to see these numbers. 363,300 kilometers, 405,500 kilometers. So probably back in elementary school that you learned that the orbit of the moon around the Earth is actually elliptical. How many people learned that somewhere along the way? A few people, okay? It's not a complete circle. So during part of the year, which we call perigee, the moon is slightly closer to the Earth, and during part of the year, part of its orbit, and then during part of its orbit, the moon is slightly further from the Earth, and that part of its ellipsis is called apogee. Not that you really need to know those terms, obviously. Okay, so when the moon is further away from us, it's not quite big enough to cover up the whole sun. So then we see an annular eclipse like this. And when it's closer to us, it can completely cover up the sun, and then we see a total eclipse instead. Does that make sense? Okay, so we're going to do a little demonstration of this. If you don't know the person sitting next to you, go ahead and introduce yourselves. Or if nobody's next to you, pretend somebody's next to you. Okay, I want you to take your hand and see if you can block their face like this. Okay? Far away, put your arm all the way out, full reach. Okay? Can you block all of them? No, probably not. Unless you're sitting really close to them, maybe. Okay, now I want you to pull your hand close to you like this. And you might need to move it up a little. Can you block their face now? Yes. Okay, so that's the difference between annular. I've blocked out most of them, but not their complete face. And total, where I've blocked them completely, I can't see them at all. Good? Okay. Okay, just before you head into totality, if you're really lucky, you can see these two phenomena. And the one on the left is called Bailey's beads. And, well, what do you think that is? Not quite. Does it look like little mountains? Okay. Can you imagine that it's mountains and valleys? Here. Sort of goes up and down. Okay, and that's exactly what you're looking at, is the canyons on the moon. When the sun comes through those canyons, you can see sort of the sculpted surface of the moon, which normally we wouldn't see. Yeah, and I don't think you would see this with your eyes, with your eclipse glasses, but with a solar telescope, especially if you're NASA, you're going to see this kind of thing. But you can also, just before totality, like this is a minute before, and that's a split second before. This thing called the diamond ring, which I think is just absolutely gorgeous and well named. All right. Here's a math problem for any mathematicians in here or former math teachers. The Earth is the only planet that can experience total solar eclipses, even though other planets do have moons, right? Okay, so what do these four numbers represent, and what's the relationship between them? And I kind of played a nasty trick on you here by not giving you any units.
I think the 150 million and the 1,391,000 are the distance to
the sun is the top and the moon is the 1,000,003.
Judy, are you my ringer in the audience? Okay, that number is the distance to the sun, and this number is the distance to the moon.
But I don't know what the other two
Oh, sorry. Distance to the sun, distance to the moon. Okay, and so what could those represent? Distance to the sun, distance to the moon. Yes, who said that? Gold star. Okay, diameter of the sun, diameter of the moon. Now, if you quickly do that math in your head, about what kind of ratio do you get there? Okay. When we did this in a physics class last week, some real smart kid said it's about 400. Oh, there we go. So the sun is 400 times bigger than the moon, approximately. It's also 400 times further away from us than the moon. Okay, so mathematically what that means to us is that the sun and the moon look the same size to us. That's why the moon here can completely block the sun. But on other planets, the moons are substantially smaller than the planet, and the distance is different. And they can't get that proper configuration of distance and diameter to completely block the sun. Now, when the astronauts went to the moon back in the 60s, okay, I'm guessing most people in here remember that. Yes? It was pretty phenomenal when they got to the moon, wasn't it? Okay. They left behind a bunch of mirrors on the moon, and we can use those mirrors to measure the distance from us to the moon. And it turns out that the moon is moving away from us at about 3.8 centimeters per year, which is around 2 inches, a little bit less. So about 2 inches per year. And so that means at some point, this like perfect ratio thing will no longer work, and we will not have total eclipses anymore. But that will be in like 620 million years. So I don't think we have to worry about it too much. Yeah, we won't be here to see it. Not sure who will be here to see it at that point. Probably horseshoe crabs, because they've been here forever. I mean, in all seriousness, horseshoe crabs have a lot of eyes, and they have pretty good vision, and they navigate by the sun, and so they could very well be looking at eclipses 620 million years from now. All right, so it actually turns out that the Earth's moon is kind of special. So for one thing, it's really big in compared to other moons, like the comparison of the moon to the size of the planet that it's connected to. So for Earth, our moon is about 25% of our diameter, which is big. But for the next runner-up, which is Triton, which is the moon on Neptune, it's only 5%. So 25% for us, and the next closest one is only 5%. So that's not very big. And that has to do with how the moons actually formed. And so most of the moons formed by accretion, which means there was a whole bunch of stuff floating around in space, kind of got sucked into the gravitational pull of whatever planet it was closest to while all this stuff was forming, and got trapped in that gravitational pull and now is orbiting around as a moon. But how we think our moon formed is actually quite different. So at some point in the past, a giant space object hypothesized to be about the size of Mars. That's big, okay? Hit the Earth and whacked off a giant piece of the Earth, 1/4 of the Earth, essentially. And that piece went flying out into space, but got caught in our gravitational pull and now orbits around us as the moon. And one of the best pieces of evidence for that is when the astronauts went to the moon. Do you remember they brought back space rocks? Yeah, and those rocks have the same composition as rocks on Earth, which isn't necessarily true of other places. And so they're like, this kind of looks like a piece of Earth. And it kind of is. I remember when they brought those rocks back, and I was like about 8 at the time. And we lived in Washington, D.C., and we went to see them at the Smithsonian. And it was a line, probably like 5 hours long, to get in to see these rocks. And then you go and you look at it, and it's like, yeah, it's a rock. But it was a really important rock. About the same time, we stood in a line for like 5 hours to go and see the pandas that came from China right around that same time. And I'm like, ooh, pandas, rock pandas. But anyway, this theory is called the Big Splat, which I think is like one of the best names. So we have the Big Bang, and then we have the Big Splat, how we think the moon actually formed.
So is that why you're a biologist?
No, actually, I love geology, and I collect fossils and rocks and all kinds of stuff. Yeah. But yes, biologist. Actually, I'm an environmental scientist at heart, because then you can put the two together, and that's the best possible thing. And throw in some weather and some other stuff, too. So, okay. I am not, however, a physicist, and this is the part where usually Andrew takes over, but I'm going to soldier on. Okay, so we've all heard of Einstein. Yes, this theory of relativity, right, which nobody except Einstein and 2 super smart physicists understand. But in Einstein's theory of relativity, the light from a star, if it's coming past the sun, should be bent by the gravitational pull of the sun itself. Okay, this is what Einstein predicted. And he said, if that's true, then a star that looks like it's there should actually be here. And we can measure that slight little difference in between those two lines. And so in 1919, there was a total solar eclipse. And a scientist named Arthur Eddington went out there to try to experimentally prove this. And he had 3 different sites where he set up telescopes and measurement equipment and so forth. And he used 3 in case it was cloudy. And 2 of those locations turned out to be cloudy, but he was lucky, and the 3rd one was clear. And so they were actually able to measure that angle that Einstein predicted and photograph it. And so this is the photo that they took. And these little black dashed lines are showing you the location of different stars that were exactly where Einstein predicted they would be if relativity were true. So that was good, proof of that theory. And I love the headline here. Lights all askew in the heavens. Men of science, more or less agog over results of eclipse observations. Do you ever see the word agog anywhere anymore? Not really. Okay. Einstein theory triumphs. All right, now down here. Stars not where they seemed or were calculated to be, but nobody need worry. Okay, good. Dodged a bullet on that one. Okay, so that's now called the Eddington experiment, and it was one of the proofs of Einstein's theory. All right, so we mentioned the corona a couple times here, and the corona is that outer, it's essentially like the sun's atmosphere. So the surface of the sun is called the photosphere. It's super bright, and because it's so bright, we normally don't see the corona of the sun itself. And because of that, it's very difficult to study. And we know that it's not very dense, but also that it's super hot. And we don't really know why. And so one of the things that happens during an eclipse, because the moon blocks the photosphere and we can actually see the corona, scientists can study the corona during that time frame. 4 minutes and 38 seconds, you better do your science fast. But in all practicality, there are ways that you can do this from Earth using telescopes that have special filters on them that can block out the corona, and the photosphere, so you can see the corona. And also from satellite-based systems, they're also able to do this. So they can study the corona at other times, but during an eclipse is really the best time to be able to study it from Earth. And so this is really, for astronomers that are gearing up to be able to do some of this kind of work during that time. So the question is, why do we want to know about the corona? Aside from the fact that we just don't really understand it very well, does this have any practical implications? Kind of. All right, so this is what I mentioned before about the sun having a cycle of about 11 years, where it goes from sort of like minimum activity level to maximum activity level. And when it's sort of at its maximum is when we get solar flares that you were mentioning before, and sunspots, and these things called mass ejections, where it's literally just throwing like great big pieces of plasma towards the Earth. And so you can see there a video of that happening. And it turns out that this year, during this eclipse, is going to be pretty close to the solar maximum. So that's another reason why astronomers are really excited about this eclipse, because not only will they be able to see the corona, but they may be able to see a mass ejection like that, sunspots, and other things that are otherwise hard to observe. And because the sun will be at its maximum activity, there's a better chances of those things happening and us being able to see it. Now, why this matters, aside from the fact that it's just cool to see it, is that all of this radiation coming off the sun creates this thing called solar weather. And a kind of nice version of solar weather is the northern lights, or the aurora. So one thing is, when we're at a maximum, when the sun is at its maximum activity level, the auroras are more common and also come further south. So in the next couple years, you may hear, in fact, I heard a few reports of it in Boston this winter, people observing the aurora just because it's further south than normally you would see it. So when we have an aurora like this, what's happening is all that radiation that's coming from the sun, it hits the molecules in the atmosphere, and it excites the electrons that are in the molecules, like oxygen, for example. And when those electrons are excited, here comes some chemistry. When those electrons are excited, they move up in energy level. They go from like the first shell to the second shell, if this is bringing back any memory from chemistry days. And when they fall back down to their like normal energy state, they give off light. And the different colors come about depending on which molecule in the atmosphere is actually being hit by that radiation and having its electrons excited. And that's why we see the different colors. Now, right now this looks like, this is just a cool, fun thing to see. But the radiation that's coming from the atmosphere can actually be pretty dangerous. And normally that radiation is also deflected by the magnetic fields around the Earth. So fortunately for us, because otherwise we're directly in its path and we'd really literally be fried by that radiation. So during a time of very active solar energy, which was in the mid-1800s, I want to say, there was a massive amount of solar flares that came to Earth. And what ended up happening was it like shut down the railroad systems because they all had like electricals, it must have been late 1800s, electrical switching mechanisms, and the mechanisms were fried. Now, at the same time, they were using telegraph systems, and the telegraph operators disconnected their telegraphs from the batteries and were able to run their telegraphs for 2 hours with no electricity, just from the flare that came from the sun. So now I want you to think about like how many electronic things we have now. Not electrical, well, we probably have electrical switching in railroads still. We certainly don't have telegraphs. But think about all the electrical things, GPS systems, satellite navigation, communication systems, your cell phone. And, if you get a massive flare, that stuff could be destroyed. And nowadays that would have, huge implications for our lives. Okay, so we're talking a little bit about how, what scientists want to study during solar eclipses, and there are a bunch of citizen science places that websites that you can go to if you want to participate in any of this. Some of them you have to have pretty sophisticated telescopes to be able to do some of their observations, but some of them are very simple things you can do. There's apps that you can download for your cell phone, for example, to be able to take pictures and upload them to different sites. The National Park Service is asking people to record animal sounds in their area, because when the skies go dark, the animals start behaviorally to react to that. Birds stop singing, and things that are only active at night come out for a few minutes. So the Park Service is trying to monitor that. There are other sites where you can report weather data, temperatures, because temperatures decrease during an eclipse. And so if you're interested in any of that, you can check out this NASA Citizen Science page and see what you can do to help out with some science research. All right, so let's talk a little bit about safety. This is where we're kind of starting with the kids. We want to make sure that everybody's safe when they're watching the eclipse. So I also want to debunk a fallacy that a lot of people have this idea that it's somehow more dangerous to look at the sun during an eclipse than on any other day, and that's not true. I mean, I hope you all realize you shouldn't be looking at the sun on just a normal day. And I mean, if you try to look at the sun on a normal day, how do you react? It's too bright, right? You squint. Exactly. Okay. So that's like a normal protective thing to keep you from having your retinas damaged by the sun, because you wouldn't look at the sun on a normal day. But during an eclipse, you're probably more tempted to look at the sun. At least you're trying to look at the sun. So it's not like the sun is any more dangerous, but people maybe do sillier things, let's say. Okay. So first of all, please don't use sunglasses, cameras, binoculars, and so forth. Those things are not safe. In fact, binoculars and cameras can be actually more dangerous. If you are trying to take a picture with a SLR sort of camera that has a light sensor in it, it can actually fry the light sensor in your camera. So don't destroy a very expensive camera by trying to do this, unless you have a proper filter for being able to do that. And likewise with telescopes, it can damage the mirrors inside the telescopes and inside the binoculars and so forth. And if you have an expensive pair of those, you don't want to damage them that way. So eclipse glasses are safe, but it's also important that you get your glasses from a reputable source, because in the 2017 eclipse, there was such high demand for eclipse glasses that there were some nefarious, actors going on that were printing out eclipse glasses in their basement and stamping on, the code numbers that say they were safe, and they really weren't. You had no way of knowing, these things were for sale online looked like reputable places, but you really had no way of knowing if you were getting a safe pair or not. So I'm going to tell you right now, the pair that you just got is safe because it came through that SEAL program funded by the Space Science Institute, and the American Astronomical Society has approved vendors for glasses. So if you want more additional ones, you can go there and see who are approved. We bought ours from a place called American Paper Optics, and they are approved by American Astronomical Society so that we know that they're safe. But as I mentioned at the beginning, please be very careful when you're taking them home today, not to scratch them or puncture them or whatever, because then they are no longer safe. So you do want to be careful of that. Okay, here's some other ways that you can look at an eclipse. All these things are rolling away because they're all round. Judy, you want to come up and demonstrate? Yeah, come on. This is the audience participation part. Here's our sun. Please don't shine this at anybody because it's super bright. Okay.
Which angle do you want this at?
Any way you want. You just want to project it up on the wall. Oh, maybe the other way around. Yeah. Okay, can you see? So this is essentially acting like a bunch of pinhole projectors. Ooh, this is pretty groovy, isn't it? Ooh, it gets better. Okay, so obviously right now, all of those circles are just circles. They will not look like eclipses. And we've played around with this to see if you can cover it. It doesn't work because the light source is too close. Okay, that would be a good look. This on your head, eclipse glasses, yeah.
And I can bring in radio stations.
So anyway, this is a way that if you have like a larger sort of group and you want a lot of people to be able to see all at once,
They all look through this?
nope, you just watch it on a wall like that, okay?
Oh,
Now, as I was saying right now, or on the ground, yep, and as I was saying right now, like the flashlight is too small and too close. With the sun's rays, you will actually see what will look like, well here, it will look like the eclipse. It will look like a crescent, right?
Is that what they were using in that?
Right there, yeah. Okay.
Strainer hole is a mini eclipse, basically.
Yeah, exactly. Yep. Okay, so that's a fun thing. Paul, you want to come on up here and do the next one? Yes? Calling all my teacher friends in the audience today. You thought the eclipse was fun. I mean, the calendar was fun. Where do you see this? Okay, you're going to shine it that way. Woo! Okay, if we hold it still.
Yeah.
Okay, and again, we're too close here, but with the sun's rays, all of those little rectangles projected on the ceiling and on the wall will be an image of the eclipse. So this is another way you can, show an eclipse to a large group of people all at once. Okay, Sue Netto. You didn't think you were going to get off the hook, did you? Okay, this is a pinhole projector.
Okay, where do you want me to stand?
So you hold that, and you're going to look through that square right there.
I'm going to look through it. Like
Yep,
that? Okay.
yep. And I'm just going to go to the next slide so everybody else can kind of see what's going on here. So Sue is looking through a hole that we cut in the shoebox. And you should see, hopefully. Did we make a hole in this tinfoil? Do you see a
I see.
circle projected
No.
on the white paper in the back?
I see the white paper in the back, but
You
I
don't
don't
see a hole?
circle. Is there
Do you see a
in
hole there? Maybe we didn't get a hole in this
I
one.
don't think there's a hole.
So you want to go run back and get the other box in the back, and we'll see.
Is it?
There's two more back there. Maybe we didn't make a hole in this one. But anyway, you get the idea of what's going on here. You hold this so that the light goes through the little pinhole, and there's tinfoil there. And then what she should see is a little white circle of light back here from the flashlight. But obviously when this is an eclipse, you would see the actual image of the eclipse there. Okay, let's test this one. Okay, I can see the hole in this one.
Oh, I see it.
Aha, yay, success.
It's
Okay,
there.
good. All right, you can just put that on the floor. Thank you. So those are all fun ways that you can look at the eclipse. You can have, if you got kids or grandchildren, you can have them make a little pinhole projector box. I'm going to say that I put together these eclipse teaching kits for all the schools. So they have colanders, and they have pinhole projector boxes, and they've got disco balls. And they also have this, so you can be the moon. Oops, need somebody else to be the sun. And you shine that towards me, but hopefully not in my eyes, please. And you can play around with where do I see the eclipse? The moon is too high, the moon is too low, the moon's too far to the left or the right. Oh, right here, sweet spot. Close enough, too far away. So kids can play with this and take some measurements and see, when does an eclipse happen? When does a lunar eclipse happen? Yeah, moon's got to be on the other side. Okay, so lots of fun stuff for kids to play around with. The teachers have these kits already. And then we also put some books in there. This is a library after all. And I love reading, so of course I had to put some books in there. And actually a lot of elementary science instruction sort of happens around what are called trade books. So here we have 2 books that are elementary level. This is an absolutely gorgeous book. If you have kids or grandchildren, buy them that book. I'm not getting any kickbacks, I promise you. But it's a beautiful book. And the one over here on the right is sort of like more middle school level. It's about 2 grandparents who go and see an eclipse and then come back and teach their grandchildren all about it. Really nice books. And so we put together for the teachers a much shorter version of this slideshow. We have multiple versions of this slideshow for different grade levels and a whole bunch of resources that they can go to that has lesson plans for different grade levels. Some like sort of data collection sort of things that they can do. This eye chart is kind of interesting. So unless you have a fancy light meter, how do you tell how much darker it's getting? Well, if you have just an eye chart from a, eye doctor's office or this one that you can get online, and you have it at a certain distance, you actually see the letters disappear as it gets darker. So what line can you read? Well, at the beginning, you can see all of them, and then as it gets darker, you start to lose those smaller ones, right? And again, recording weather and animal sounds, temperature, and so forth. And those are some slightly higher grade level lesson plans that we have for middle and high school students. And then, okay, what about the elephant in the room? I don't even want to think about this, but if we get a day like today? Unfortunately, there's a website where you can go to and see like what is the average cloud cover on your day for any day for the last 50 years, because of course we have all that data, and it's cloudy in April often, we know that. So what if it is? Well, this organization called the Exploratorium, they're a museum, science museum in San Francisco, and they made a phenomenal video during the 2023 eclipse in October. They were at Valley of the Gods, which is in Utah. And first of all, it's worth watching just because Valley of the Gods is such a beautiful place. It's that sort of red rock geology, okay? And then it's a part of, I'm not sure if it's part of the Navajo reservation, or at least it's ancestrally Navajo land. And so they have a number of Navajo elders who, during the video, talk about what historically the Navajo thought about eclipses, how they interpreted them, what they meant for sort of their own culture. And they extend that to some other native tribes as well. And then they have a whole lot of eclipse scientists that come in to talk about what's happening. And because the whole eclipse is like 2.5 hours, so they were kind of waiting for the big event for it to go annular. And the 2 women who are the hosts of this video are just so excited when the eclipse actually starts. And you can see they start to shiver because it's getting cold as it gets darker. So they are going to be live streaming again. They have, I think, 3 different places set up. NASA will be live streaming. There's another place called Date and Time, I want to say. A number of organizations that are live streaming. So, worst case scenario, if we can't see it live, we can at least experience it through these different sites. And it's worth kind of, I think, probably that day, going back and forth between the different sites to see what kind of view they might have or what kind of expert they have speaking at that time. By the way, this video is available online. It is also being shown at the Woods Hole Library on April 1st and April 3rd, I want to say. There was an article about it in the Enterprise yesterday. I just happened to be at the Woods Hole Library yesterday, and I saw their flyer, and then it was in the paper yesterday. So if you're interested in watching that, you could go and see it there. And I was going to take you all outside and show you the sun spotter, but the weather didn't cooperate. So I'm taking that as a good sign that it's going to cooperate on April 8th. But the sun spotter is in the back of the room. There's pinhole projectors. I'll put this other fun toys back there. There's some posters you can look at. The books that I showed you are back there. If you want to take a look at any of those things, feel free. And also, if you somehow missed getting a pair of glasses on your way in, make sure you pick up one before you go. Whew, and I'm going to say, are there any questions? Yes?
With 90%
Ooh,
here,
excuse me.
will it be dark there with 90% coverage?
Yeah, so I asked one of the astronomers in the webinar that I was attending, I said it's going to be between 80 and 90%. I didn't know the actual maximum at that time, which turns out to be 90. And he said borderline. 80 probably not, 90 possibly. When you see that just little teeny strip, but the sun is so bright that even with that little strip, we may not,
I'm going to New Hampshire.
it may not get dark. It may get a little darker. I mean, the same way that it's darker today than on a completely sunny day, but I don't think it's going to be like night looking here. But could prove me wrong. I don't know.
Is like in the path of totality, it
Mhm.
will be night, but what if
It will
you're-
be dark.
What if you're, oh, it'll be dark.
Yeah.
But what if you're like almost to, like in
I would say the closer you are, the darker it's going to look. Yeah. So if you can, go visit friends in New Hampshire or wherever. You want to see the map? Who do I know in New Hampshire? Yeah.
Will the traffic be crazy, do you think?
Okay, so that's actually a really interesting question. In the states that are experiencing totality, their state emergency management systems and first responders and hospitals and state police and everybody are gearing up for this because they think they're going to have an influx of people, and I think they probably are. And they're projecting that there's going to be traffic jams, and they're telling you, I mean, this is getting a little bit Armageddon-ish, but they're telling you, bring food, bring water, bring spare clothes. You know, I'm like, okay, this is not like getting stranded in a blizzard. Eventually, you're on the New York State Thruway. Hopefully, you get home. But in all seriousness, yeah, they're looking very serious at this because they're expecting a lot of people to travel. Yeah, a lot of schools are actually closed the day of the eclipse, the ones that are in totality. First, because everybody's going to stay home anyway, so you're fighting an uphill battle there. And secondly, because they are worried about, you know, just the massive influx of people to their towns and trying to deal with that crowd and school kids and school buses. And yeah, there are also, I hate to say it, some uninformed schools where the leadership has said we can't guarantee the kids will be safe, so we're not going to let them go outside and watch the eclipse. You're like, okay, if I were a parent, I would keep my kid home that day. Don't listen to this, Falmouth Public Schools. I mean, we've made arrangements for our kids to be able to watch it. That's a big part of what we're trying to do here is get everybody glasses and teach them about the eclipse, use it as a teaching resource, let them learn how to watch it safely, because there are ways to watch it safely. Yeah.
Do you think some of the children might have behavioral issues with, children can be children and take them off?
Well, again, it's really hard to look at the sun
So-
even on a regular day. We are trying to stress that when they're looking at the eclipse, they need to have the glasses on. Now, there's a little bit of debate about younger kids because those glasses are kind of one size fits all. So there's a way that you can take a paper plate if you have got grandchildren and you want to do this, and our preschoolers may do this. You can take a paper plate, cut out the eye holes, put the glasses over it, put a elastic around the back, and basically wear it like a mask. And then you decorate it like a panda or a fox or whatever animal you like, and you have an animal mask and you use that to watch the eclipse. Now, I also know like your average preschooler has an attention span of about 3 minutes. So they're going to be like, oh, an eclipse, and then they're going to run off on the playground. So, yeah, but they got to see it. Yeah.
I have a question.
Yes.
So there's really good information on that slide deck. Is that available through the library website, or should I have been taking pictures of all the information?
Okay, I can ask the library if there's a way for that to happen. Clint, is there a way for that to happen?
It is.
Okay.
I'm just curious.
Well,
Can you put it in the enterprise?
I'm sorry, I couldn't hear what you said.
I'm not aware of the plans.
Okay,
Sorry, I can't speak on that.
yeah.
But that is definitely something we've done in the past.
Okay, so we actually have someone from FCTV here today recording this, so it will be on the TV. I have a Falmouth Public School email address, so if you want to email me, I can send it to you. I've shared it with basically all the teachers in the district, so if you know another teacher, you could contact them as well. But Okay, I realize I forgot to say this, and super important, because these are the organizations that sponsored buying the Eclipse glasses and all the teaching materials that we got, including the books and posters and so forth for the elementary school. So Woods Hole Science and Technology Education Partnership, MIT Club of Cape Cod, and Salt Pond Area Bird Sanctuaries, Hollis and Ermine Level Future Fund that gave us the money to put this program together. Okay, other questions? Yes, in the back.
Two questions. One, how are the glasses made? What's different about them? And two, do our animals outside, do you have to worry about them? Or are you just wild animals?
Okay, so I'm not sure exactly what those glasses are made out of. I have read that, but I just don't remember what the material is. But if when you leave here today, if you put them on outside, you will not be able to see where you're walking. That's how dark they are. Or I saw a few people trying them out before.
Like welders.
They're exactly like welder's glasses. You cannot see. Okay, and then when you actually wear them, the sky will look completely dark except for the sun. Yeah. If you put them on now, you won't be able to see anything in here. As far as wild animals, the way they respond is if they're normally diurnal, active during the day, they like shut down, like it's nighttime. They're like, okay, it's time to go into my burrow or wherever.
How about your dog,
Yeah, I don't know, how often does your dog look at the sun? They're always sniffing something, right? So that's why I'm saying, I've seen pictures of dogs wearing eclipse glasses, but I'm sure it was just somebody having fun with their dog. It's not like the dog cares that there's an eclipse going on. So I think this is mostly like a human thing for us to worry about. Yeah. Yes, question here.
Do you have any details about the library's plan to have us all gather at the lawn?
Yeah, so Clint, do you want to say something about, she's asking about the library watch party on April 8th. Do you want to say something about that?
Sure, absolutely. So you guys all have your glasses, and if you don't have your glasses, make sure you don't leave without them. And so weather permitting is a big one. We will having a viewing party out on the lawn. You can bring, your chairs, your lawn chairs and everything, and have some snacks and water and stuff, and we'll have a nice time all together, talking about it, watching it, and it should be a great time.
Would it be a telescope, a giant telescope to the little library dog?
Okay, so the question was, will we have a telescope? So we have that sun spotter telescope that's in the back there, and we also have another one that we're trying to convert to. It is a solar scope, but it needs a special filter on the front, and we're trying to get that to work right now. So it was kind of our plan to set this up at Mullen Hall, which is right across the street, because then the problem is, we would like to have this at the high school, but the high school kids will all be long gone before the eclipse even starts, because we get out at 2:05. So we were thinking if we had these things set up here at Mullen Hall, and people were at the library, they could see them across the street, or we could bring them over. Again, it's a 2.5-hour time frame, and the kids aren't going to watch for probably that long, and they will be getting on the bus and going home. So we have the equipment, and if we can work it out, we'll try to do that. Also, I hear from Jessica, who's organizing this event, there's going to be an eclipse playlist of music, so that will be fun. And we've had a couple of eclipse teacher workshops where we've had, eclipse themed snacks. So if you want to have just a party at your house, here's what I'm recommending: half moon cookies, okay, sun chips. There's some kind of seltzer kind of stuff called Soleil. I've never had it, but Milky Way bars is another one. Right now, this is product placement totally. Right now, there's Oreos are making some kind of space junk cupcakes and cookies and stuff. But anyway, if you go shopping around your grocery store, you're going to find a whole lot of fun space-themed food. Oh, moon pies, yep. Starburst was another one. So yeah, all healthy, nutritious things to watch during an eclipse. So. There was one other person that had their hand up a minute ago in the back, but maybe I got you. I can't remember. Good? Okay. Thank you very much. Thank you for coming. Thank you for that question. Good advertisement.